this demo, we will show you how our high-speed encryption solution for data in motion can help you secure your network, save you time on key rotation, and give you your bandwidth back. HSE is a secure overlay to your network that can be dropped into an existing architecture. No network changes need to be made. We want to let the networking devices do what they do best, which is route and switch. The method of abstracting the security layer from the network is creating a separation of duties, allowing the security team to manage the encryption of data in motion. The diagram shows two AWS VPCs, each having its own HSE protecting all data passing through it. In this example, we have a Linux server sitting in a private subnet and the HSE protecting all data flowing in and out. This demo will show two throughput tests using iPerf, which is a standard network performance tool. The first will be a baseline test with no encryption. The second will be a test with encryption enabled on our HSEs. Traffic will flow from Linux server A to Linux server B. In this example, we're going through an internet gateway, but this could also be a direct connect, express route, etc. Flow in the local NIC and will be encrypted as it goes out the network NIC. When the HSE in the remote side receives the traffic, it will be decrypted, providing a secure transport with optimal performance. Here we can see the HSE is set to bypass mode, which means no traffic will be encrypted. What you're seeing here is a baseline throughput test using iPerf with no encryption. Server A on the left is initiating an iPerf test to server B on the right. The performance dial on the bottom of the screen is the NIC on server B showing the data received. As you can see, we are getting about 5 gig throughput with no encryption enabled. We will enable encryption by changing the global operation mode from bypass to encrypt all. This means all traffic flowing through will be encrypted unless we set bypass or discard rules later. Transport independent mode will be enabled. TIM is a feature that allows encryption of layer 2, 3, and 4. The versatility and convenience of this feature allows networking security administrators to spend less time managing IPsec tunnels and more time on projects they would rather be working on. We'll enable the highest level of encryption, which is AES 256, also with GCM authentication. We also support cipher feedback and counter modes. Using TIM mode, we utilize a KDF or key derivation function, which is FIPS approved and secure. Output is indistinguishable from random number generation. Keys are updated frequently. We can also leverage an external key management system, such as a separate trust manager shown above. Auto discovery will allow the HSEs to learn connections from other HSEs in the network. Notice in the connection sections that you can see what HSEs have been discovered. You'll also notice the key number. This is useful because you will have the confidence that your links are secure with automatic key rotation. Keys will be rotated by counter or time depending on the policy used. We're adding an IP rule for the public IP of the remote Linux server. We have the flexibility of specifying ranges or specific IPs. We can specify certain protocols such as TCP, UDP, etc. We can wildcard or specify specific port numbers, and then we can specify how the traffic is processed, such as encrypted at layer 2, 3, or 4, or discarded or bypassed. Traffic from an unlisted IP can be configured as discarded, bypassed, or encrypted. Here you can see the same iPerf test done previously with the addition of encryption being enabled. As you can see, we are getting the same throughput at around 5 gigabits per second. Why does this matter? Well, let's compare packets. The first packet is an example of the original packet without any encryption. The second is an example of the IPsec encrypted packet with quite a bit of overhead there. The third is a packet with our encryption. As you can guess, this is how we can encrypt and give you your bandwidth back. You can now have a highly secure connection and high bandwidth. You no longer have to feel the pain of managing IPsec or MACsec. Now understanding the value of the HSE, it's important to know where it can be deployed. So essentially anywhere. It could be a headquarters, branch office, data center, cloud. The connection could be MPLS, IP, could be SD-WAN, could be cloud to cloud, could be direct connect, express route. Today is an example of the CV1000 generic architecture. It has 3 individual NICs, one for local, one for network, one for management. We have another version that supports the AWS Gateway Load Balancer, supporting the Geneve encapsulation. For clouds that offer the Geneve encapsulation utilizing a gateway load balancer, we can leverage multiple HSEs, such as on the right of this diagram. You see that there are 4 HSEs aggregating that load from that 100 gig direct connect.